Welcome back, dear learners. Building on the foundations we have established, we are now venturing into the exciting realm of deep learning. I hope you have benefited from my previous lectures, and I am eager to share with you the powerful technique that will shape the future of research that is known as deep learning. Learning deep learning is important because it helps machines learn from large amounts of data and make smart decisions similar to how humans learn from experience. It powers many modern technologies like face recognition, voice assistance, language translation, and self driving cars. By understanding deep learning, anyone can explore how intelligent systems work and even create their own smart applications. It is useful in fields like healthcare, finance, education, and automation. Deep learning also helps solve real world problems more accurately and efficiently. As AI continues to grow, learning deep learning opens up exciting opportunities, and it is a valuable skill for anyone interested in the future technology. We'll see one by one. First, what is deep learning? Deep learning is a subset of machine learning. Deep learning is a specialized branch of machine learning that focuses on using algorithms known as artificial neural networks to automatically learn patterns from data. While traditional machine learning requires manual intervention for feature selection, deep learning allows a system to discover patterns directly from raw data and making it more autonomous and powerful for certain tasks. And it uses mathematical functions to map input to output. At the core of deep learning are mathematical functions that transform inputs into outputs by modeling the relationship between them. These functions often involve operations such as weighted sums and activation functions, enabling the network to make decisions, predictions, or classifications based on the input data. And it extracts non redundant patterns from data. Deep learning models are exceptionally good at filtering through vast amount of data to identify unique, non-redundant features that are essential for making accurate predictions. This ability is crucial, especially when dealing with high dimensional data like images, audio, or text, where important patterns are hidden beneath layers of noise and redundancy. And this pattern recognition process is called learning. Learning in deep learning refers to the model's ability to adjust its internal parameters, primarily weights and biases, based on the data it processes. This enables the model to improve over time by recognizing which features lead to accurate outputs and which do not. And the model learns during a process called training. Training is the process where the deep learning model iteratively updates its internal parameters using algorithms such as backpropagation and gradient descent. This process involves feeding large data sets through the network and adjusting the parameters based on the difference between the predicted output and the actual result, that is the loss function. Next, why deep learning became popular recently. The first point is, although theorized in the year 1980s, it became practical due to the concepts of deep learning dates back several decades, but it was largely theoretical due to computational and data limitations. Only in recent years, with advancements in hardware and the explosion of digital data, has deep learning become a practical tool for solving real world problems. That is availability of large labeled data sets. That means modern deep learning thrives on massive labeled data sets that helps models learn intricate patterns and relationships. And data sets such as ImageNet have enabled breakthrough in the image recognition by providing millions of labeled examples that models can use to learn accurate classifications. Next, growth in computational power. Example, high performing GPUs. Training deep learning models require immense computational resources. The development of powerful GPUs, that is, graphics processing units, and specialized hardwares like TPUs, tensor processing units, has made it feasible to train complex neural networks in a reasonable amount of time, unlocking the full potential of deep learning. Next, neural networks, that is the core of deep learning. Deep learning uses artificial neural networks. Artificial neural networks are the building blocks of deep learning. Inspired by the structure of the human brain, these networks consist of layers of interconnected nodes, that is neurons, that process and transmit information, and each node performs a mathematical computation that helps the network learn from data. And neural network consists of stacked mathematical functions. That means the layer in a neural network apply a series of mathematical operations to the input data. Each layer transforms the input into the slightly more abstract representation, eventually producing an output that can be interpreted as a prediction or classification. And these functions are organized into the layers, adding depth. That means the depth of the neural networks refers to the number of layers it has. A shallow network may have only one or two layers, while a deep network can have dozens or even hundreds. These layers allow the models to learn increasingly abstract and complex representations of the data. This structure gives rise to the term deep learning. The term deep in the deep learning here deep learning. huh? Deep learning signifies the use of multiple hidden layers in a neural network. The depth enables the modern model to capture hierarchical features in data, making it particularly effective for complex tasks like image recognition and natural language processing. Next, coming into the what is the difference between deep learning and machine learning? Deep learning versus machine learning. Deep learning can do everything machine learning can and more. Deep learning encompasses the capabilities of traditional machine learning but extends them further. While machine learning can effectively handle simpler, structured data sets, and deep learning can tackle more complex and unstructured data, learning directly from raw inputs with minimal human intervention. Next, machine learning is better suited for small, that is curated data sets. That means traditional machine learning algorithms perform best when data set is clean, well labeled, and not excessively large. Okay, so these models rely on handcrafted features which can be effective for specific tasks but require significant domain knowledge and pre processing. In traditional machine learning, humans are often needed to select relevant features and prepare the data set before training. This pre processing step can be time consuming and may introduce bias, limiting the model's ability to generalize. And deep learning excels with large, complex data sets. How means deep learning models are designed to handle high volumes of complex and unstructured data. With the ability to learn hierarchical features, these models can process raw images, text or audio directly without the need for manual feature engineering and minimal need for manual feature extraction. Unlike traditional methods, deep learning can automatically learn the most relevant features from the data during training. This reduces the reliance on human expertise and allows models to uncover patterns that might be overlooked in a manually curated data set. Next, deep learning versus shallow learning. Traditional machine learning, we are calling it as the shallow learning. Shallow learning refers to the machine learning model that have a limited number of processing layers, typically one or two. These models are simpler and faster to train, but often struggle with complex or high dimensional data. And the shallow learning works well with the smaller data sets. When data is limited, shallow learning models are often preferred because they require fewer parameters to train and are less likely to overfit. They are efficient for well defined problems with clean labeled data. And deep learning can handle large scale complex data. Deep learning thrives when applied to large data sets with many features or dimensions. Its layered architecture enables it to identify intricate patterns and relationships that shallow models would miss or misinterpret. Learn complex patterns automatically. One of the defining feature of deep learning is its ability to learn highly abstract features without manual intervention. This allows it to solve tasks like facial recognition, sentiment analysis, and language translation with a high accuracy. Next, advantages of deep learning. It can process unstructured data like text, images, and social media. Unlike traditional models, deep learning can directly handle unstructured data such as audio, video, images, and text. This makes it invaluable for fields like computer vision, natural language processing, and recommendation system. And it is capable of generating new data samples. That means new deep learning models such as generative adversarial network GANs and the variational autoencoders VAEs can create entirely new data samples that resemble the original data sets. This is useful for creative applications like art generation, data augmentation, and simulation. And it detecting anomalies often missed by human or ML. Deep learning is adept at identifying subtle anomalies in data that are difficult for humans or shallow models to detect. This capability is especially useful in fields like fraud detection, cybersecurity, and predictive maintenance. Next, deep learning and AI, artificial intelligence. Deep learning is a major approach in artificial intelligence. Deep learning has emerged as a foundational component of modern artificial intelligence. It enables machines to perform tasks that typically require human intelligence, such as vision, speech recognition, and decision making, and it combines advanced algorithms with powerful hardware. The effectiveness of deep learning stems from both the sophistication of its algorithms and the availability of powerful computing infrastructure. Together, they allow models to process massive amounts of data and learn from it in the meaningful ways. And it solves problems requiring human like intelligence. Deep learning applications are increasingly solving problems that were once thought to require uniquely human cognitive skills. From self driving cars to medical diagnosis and virtual assistants, deep learning is at the forefront of creating systems that mimic intelligent behavior. And coming into the summary, deep learning learns from large raw data. One of the key strengths of deep learning is its ability to learn directly from raw, unprocessed data. This eliminates the need for extensive preprocessing and allows the model to discover features that are most relevant for the task at hand. And it uses neural networks for pattern recognition. At the heart of deep learning are neural networks, which excel at recognizing patterns in data. These networks can model complex relationships and make predictions based on prior learning, and it outperforms ML on machine learning on complex tasks. While traditional machine learning has its place, deep learning significantly outperforms it on complex tasks involving image, speech and language processing. Its flexibility and accuracy have made it the go-to solution for modern that is challenges. And driving force behind many AI advancements means deep learning is responsible for many of the recent breakthroughs in artificial intelligence. Its capacity to handle large data sets and to deliver human level performance in certain domain makes it a driving force in technology, science, and industry. So, coming into the conclusion, deep learning is a powerful technology that enables machines to learn from data and make intelligent decisions, playing a major role in shaping the futures across various fields. It offers vast opportunities in innovation, automation, and problem solving across industries like healthcare, finance, and transportation. Hope everyone understood the topic, enjoyed learning something new, and found the session informative and engaging. Thank you for your patient listening. Thank you once again.